Oh, hi friends. It's your neighborhood struggling college student, Juliana. Have I ever talked to you about the most paradoxical substance in our day-to-day lives? It is so critical to life here on our planet that when we look for extraterrestrial life, this is the first thing that we look for. The only substance that naturally exists as a solid, liquid, and gas on our planet. We even set our scientific benchmarks by this one magical substance: water.
To talk about water and its properties, we first have to understand hydrogen bonding. Water is made up of 3 molecules, 2 hydrogens and 1 oxygen. These atoms bond through covalent bonding and form a bent V shape. Because the oxygen is more electronegative than the hydrogen, there is a slight negative charge near the oxygen and a slight positive charge near the hydrogens. This makes water a polar molecule. Hydrogen bonding is largely what causes water to act so different from other molecules. Here are some molecules that are similar in shape, weight, and polarity, but exhibit wildly different properties, like specific heats, phase changes, and viscosity.
You may be wondering, Juliana, who cares? Water is like lame. I only drink almond milk and Diet Coke. You should care. Life on this planet would not exist as we know it without water. Let me show you.
First, let's talk about specific heat. Look at the temperature of the heated acetone and the water. Do you see how fast the acetone cools off when compared to the water? Water has the highest specific heat of any liquid, which means that it's really, really good at holding onto heat.
This is why we take baths and fill hot tubs with water and not acetone. The world's oceans are the largest heat reservoir on Earth. If the specific heat of water was significantly lower than it is, the heat would escape Earth much more easily, cooling off the entire planet, and the world would eventually just be one chunk of ice.
The second most important property of water is its viscosity, or its ability to stick to itself, forming a chain to pull on each other. This can be shown in how water will climb this paper towel. This is referred to as capillary action, and it's how trees pull water from the ground up into their leaves. The last, and perhaps the most important aspect of water, is the odd way that it freezes. Water acts like any other liquid when it begins to freeze. As the temperature drops, the liquid becomes denser. However, around 4 degrees Celsius, water begins to become less dense as it freezes into a solid. This is due to the lattice structure that the hydrogen bonds form as water freezes, which in turn decreases the density of the solid. Eventually, it becomes less dense than its liquid form, causing it to float.
Ice floating on water may not be miraculous to you, but to the prehistoric amoeba that would eventually evolve into, well, us, it was pretty important. Without this discrepancy in density, ice formed at the top of a body of water would have sunk to the bottom and crushed any potential life, including our prehistoric amoeba ancestors. Water is the one molecule that exhibits this behavior. It is an anomaly in nearly every way, yet without it, we would not exist. Take time today to be thankful that you aren't crushed under thousands of pounds of ice. Thanks for watching.